Here's our first question for the sample problems for test 2. All right, so make sure that you know how to do these problems. All right, so it says we have a moon rock, and they give us the mass, and then they give us the volume. So of course they want to know the density in grams per cubic centimeter. Density, just to remind you, is mass divided by volume. And in this case, you don't have to calculate the volume. It's given to us, and it's given to us in the proper units. It's already in centimeters cubed. All right, so we're good to go there. The mass, however, is not in the right units, right? So the mass is, let's see, so 0.974, but it's kilograms, right? Kilograms. So what we have to do is we do a conversion in 1 kilogram. There are, of course, 1,000 grams, or 10 to the third grams. All right, so the kilograms cancel, and so you just multiply this by 3, 10 to the third. And so you're just going to move the decimal place 3 places to the right. Right, so this is going to be 974 grams. All right, so that's a pretty straightforward problem here. Let's complete it. So 974 grams divided by 295. 295.15 centimeters cubed. All right, so we just divide those two numbers, and we will get the density of this moon rock. All right, so let me get my, where is it? There it is. Calculator. All right, so 974 divided by, so you should be trying to do this as well. 295.15 equals. All right, so and it says to round it to 1 place past the decimal, so 3.3. Right, that's the correct answer. All right, so here so we can. I don't really have to rewrite it, but 3.3 grams per centimeter cubed. All right, so notice that they've already asked you, what is the density in grams per centimeter cubed. So really, you only have to give this numerical value. Okay, so that's what I'm looking for. All right, let's do the next problem. All right, here's our next problem. Like everything in orbit, our moon travels in an elliptical orbit. The point where the moon is closest to the Earth is called the perigee. Right? Let's see. And by the way, okay, this is just kind of an aside thing that you should be aware of. If the phase of the moon is full when perigee occurs, right? So the moon is getting further from the sun. Further from the Earth and closer to the Earth. The point where it's closest to the Earth, which is known as perigee, if that happens and coincidentally it's a full moon, right? Which that doesn't happen every single time. That's called a supermoon. That's what we call a supermoon. But by the way, it's not actually. It is a little bit bigger because the moon's slightly closer to us, but the human eye cannot perceive that. It's kind of a, you'll hear the weather people talk about, oh, it's a supermoon tonight, and you don't really see that it's that much, or that it's bigger. It's really not noticeable. All right, so anyhow, suppose a radar beam from Earth, so from the surface of Earth, bounces off the moon and returns in a round trip time, so that's the key there, of 2.422 seconds. how many kilometers is the surface of the moon away from the surface of the Earth. In other words, when you send up the radar beam, all right. So let's say that this is the Earth, and way over here is the moon. All right. So from the surface of the Earth, the radar beam travels. Right. So this is the radar beam traveling out, and then it hits the moon and then bounces back. Right. So it's bouncing back. I mean, it bounces back along the same path, but I'm just doing this to emphasize. All right. So we really want to know this distance, right? We just want to know the distance to get to the moon, right? And so that distance is equal to, well, I mean, all of it comes from this. The velocity is distance divided by time. But see, we're not interested in the round trip time. We're interested in, and so we rearrange, by the way, we rearrange this equation, just put the time on the other side of the equation, and then you get the distance is equal to the time. All right, but it's not the round trip time, right? It's the round trip time, round trip divided by 2, right? Because we don't want to know the distance to get to the moon and come back. We just want to know the distance to get to the moon. And then the other thing is, since it's radar, it's traveling at the speed of light, right? So the speed of, so in this case, v is equal to c, the speed of light. All right, so we're going to use that, and the speed of light. Since we want to know the answer in kilometers, we're going to use the speed of light in kilometers per second. All right, so this is going to be, the c here. So now I'll put the numbers in. So it's 2.4. Sorry, there's a decimal right there. 2.422 seconds divided by 2, right? Because we want half the round trip time to get for this distance, and then the speed of light is 3 times 10 to the 5th kilometers per second. And the seconds cancel, and that gives us an answer in kilometers. Okay, so at this particular point in the moon's orbit, which is known as perigee, when it's closest to the Earth, let's see how far away it is. Okay, so here I'll put the calculator right here. Let's clear that. All right, so it's going to be 2.422 divided by 2, and then times 3 times 10 to the 5th, right? Kilometers, of course. All right, and so it's 363,000. 363,300 kilometers. All right, so D turns out to be, I don't really need to write this, but 363,300 kilometers. All right, so that's perfectly fine. All right, so all right, let me look at the next problem, see if I have enough time to do it. All right, so here's the next problem. It says, suppose the circular crater Tycho, which is a very large crater in the southern hemisphere of the moon, has a diameter of 85 kilometers. So this is the actual size of this crater. It's been measured time and time again. Could a person see this crater with the unaided eye? All right, so that's a yes or no question. Show your work for any credit. The smallest angular size that the human eye can resolve is 0.5 arc minutes. Right. Use the average distance to the moon as 384,400 kilometers. All right. So really the question. So what let's write what we're solving for. So we're gonna solve for the size of a crater, and so we're gonna get some answer. So so we're gonna use the numbers that we have, and we're gonna use in this formula pi over 180 right? This is the angular size of things, times the distance to the object times the angular size of the object. And now they gave us the angular size in arc minutes, but of course this has to be in degrees, right? It has to be in degrees. All right, so we've got to change that, um, but that's pretty easy to do if you know the conversion. And so once we get an answer, the real question um, is this number bigger or less than 85, right? So that's so is this so let's say that it's I already know that it's going to be less than 85. All right, so less than 85, right, kilometers. So if that's true, then what does that mean? That means that if the number you if L script L, the size of an object, when we use an alpha of 0.5 arc minutes, if it's smaller than that, then humans could see it. It's as simple as that. All right. So let's work out the details. All right. So we have that alpha is 0.5, and it's arc minutes. Here, I'll just use a single hash mark because it's easier. So it turns out that in 1 degree there are 60 arc minutes. All right, so the arc minutes cancel. Here you can pretend that's them canceling. All right, so it's 0.5 divided by 60 degrees. All right, so we're going to get that number, and then whatever that number is, we're going to put it in here. We're going to multiply it by the average distance to the moon, and then multiply by pi, and then divide by. All right. Anyhow, so let's you can actually just do this on your calculator here. Here, let's do that. All right, here we go. All right, so 0.5 divided by 60. So this is the angular size of this thing in degrees. So that's a very so 0.0083 repeating 3 degrees. All right. So now all I have to do is multiply that times the distance to the moon. So I'm going to say times 384,400, and then times pi. Right, so times pi, and then divided by 180. Right, so does the order that you multiply doesn't matter here, of course. The order of multiplication never matters. All right, so we divide it, and so this is going to give us the size of this thing. It should be about 55.9. All right, there it is. So when we round to one place past the decimal, it's 55.9. All right, so the human eye could make out any object that is, 50, that's supposed to be a 55.9 kilometers or larger, right? And of course, this is larger. The crater at the southern, towards the southern pole of the moon. It's not right at the southern pole, otherwise we wouldn't be able to see it. But anyhow, the crater is greater than that, and so the human eye could see it. Now, it's barely visible, by the way. And I've looked at the moon for a long time, and I know exactly where to look. And it's much better if you do want to look at Tycho with any detail at all. Just a small pair of binoculars will technically you can see it because it's bigger than this 55.9, but it's not you can't see it very well. All right, so there's the first 3 problems. We're going to move on to the next ones here.